independent t-test, AFT test, ANOVA, repeated measures ANOVA, and hands-on SPSS. Day 3, we are going to cover the non-parametric test like Mann-Whitney U test, Wilcoxon rank sign test. So all the test and the content is given in your brochure for the workshop. So we will cover accordingly. So the first part, that is 1 hour of the starting, we will cover the theory part, and the second half we will cover the hands-on. So your queries will be taken after the completion of the session. In the meanwhile, you can also write your queries in the chat box, because it is not feasible to cover one by one queries in the middle of the session. So first we cover the whole session, and after the session we will take the queries from the participants. In the meanwhile, you can also write your queries in the chat box. So in the day 4, we will cover the bivariate regression analysis, logistic regression analysis, multinomial logistic regression, along with the hands-on SPSS. Day 5 is dedicated for the exploratory factor analysis. Day 6, we cover the cluster analysis. And day 7, we will cover the discriminant analysis. So this is the program schedule for upcoming 7 days. So with this, now I welcome to our esteemed resource person for today's session, Dr. Anup Kumar is with. Anup, are you there? Please unmute yourself.
Yes, Dr. Dharmendra, I am here only.
Yes. So thank you so much, sir, for being with us. Dr. Anup is a very renowned statistician and a biostatistician, and he has expertise in various statistical software like SPSS, R, and many more. So sir is currently working as associate professor in the Department of Biostatistics and Health Informatics at SDPGI Lucknow. He has done his master's and PhD from Banaras Hindu University, and he has a very reputed publication and invited talks in various national and international platforms. So sir is kind enough to always have present in our platform to share his knowledge and experience with the participants. So thank you so much, sir, for always being with us. Thank you, and over to you, sir.
Thank you, Dr. Dharmendra. So it is writing that you cannot start screen share while.
No, sir, you can. I think I have allowed sharing.
You have allowed, but somebody have opened the white screen.
So I request
Dr. Ankur Raghav.
Dr. Ankur Raghav.
Yes.
So please avoid unnecessary disturbance so that other participants can get benefited from it.
I hope this screen is visible.
Yes, sir.
Okay, so I will continue. So as narrated by Dr. Dharmendra, that this is a 1 week long workshop, and mostly first hour of all the lectures will be covering the conceptual part of fundamental of statistics and data analysis. And in the second part, we will try to demonstrate how we can do data analysis with SPSS software. So since we are talking about data analysis, and for doing the data analysis, we need to understand what is data. So this talk will be exactly that we are going to cover today. Just tell you that what is data and how we can summarize the data graphically and numerically. So this is the objective of the talk today. If you understand the data, so it will be very much easy for all of you to understand the future lectures of this workshop. Those are parametric test, non-parametric test, regression and logistic regression analysis, factor analysis, cluster analysis, and discriminant analysis. So data analysis, for doing a data analysis, we need to understand the data. 90% of the data analysis which we do or which we should do, that will be covered by today's lecture. If as a researcher we are able to summarize our data, the data which we have collected, if we are able to present our data simply by giving its graph and mean or median or standard deviation, so that the reader are able to understand the pattern.
Sir, you are on the first slide only.
Yes.
Your slides are not moving, maybe.
Yes. I didn't start
Okay.
the slides.
Okay, sir.
So that is very important for all of us to do. So, but before moving to the talk, this is a question which usually I ask to my participant, and you people can write down your answer to this question into the chat box, that why do we need statistical calculation? The participants unable to hear you. Why? To summarize the results, to have some idea about the data, to interpret. Hello, sir. I am statistical and scientific validity to understand information, to measure our result, testing hypothesis, analysis for accuracy, for inference. Okay. To analyze the result, to check data, to interpret data, inference. But let me tell you that what analyze means, most of if I will summarize the answer which I am getting from our participant, that we do statistical calculation for drawing the inference, for testing the validity, for summarizing it. But this is what we do in statistics. This is the answer, the answer which I am getting. This is what we do in statistical calculation. I'm asking, why do we do statistical calculation? So the answer, yes, I get some one option. Somebody have written, because so much variation around. SCA Bharat, one of the participant, only he have given the correct answer. We do statistical calculation because we have variability. Whenever we measure something, say for example, simply if you are measuring the height of all the students in class 5th. So obviously, when we are measuring the height of all the students in class 5th, the height of all the students are not going to be equal. They are going to get varied. Since there is variation, to understand the pattern of variation into the data, we need statistical calculation. That's it. If there is no variation, whenever we are measuring anything, whenever we are observing anything, and we do not find any sort of variation in that data, there is no need of statistical calculation, and obviously there is no need of this subject. So this subject is because of variability. So I quote here that variability is the mother of statistics. So all of you should remember. So since variability is the mother of statistics, so we should understand that what are the sources of variability, or whenever we measure something, from where does the variability comes from? So these are the three sources of variation. One is the conditional factor of interest, two, the measurement process, and third one is the experimental material. So since most of us are working into the medical background, so I will take an example, very simple example from that particular background. Say we are measuring the blood pressure of the patient who are coming to the OPD or OPD of a endocrinology department. And whenever they are coming to the OPD of endocrinology department, so we ask them, go and get your blood pressure, weight and height done before coming to a consultant. So simply if we are measuring the blood pressure of the patient, so the blood pressure of the patient is going to get varied because of the conditions of the patient, whether the patient is suffering from any disease or not. If he's suffering from hypertension or some other element, so obviously his blood pressure are going to be on a higher side. So the variability is there because of some factor, because of which the variation is there. Another source of variation into the blood pressure is of the measurement process, how we are measuring the blood pressure of the patient. Whether we are following the strict protocol of measuring the blood pressure of the patient, whether we are using electronic, or whether we are just patient is running to the nurse and or paramedical staff to get his blood pressure done, or just simply that paramedical staff without measuring his blood pressure just write down his blood pressure. Means what is the measurement process, whether they are following the WHO protocol for measuring the blood pressure or not. So the measurement process is also very much important, which may affect the blood pressure of the patient. And third is the experimental material, with how we are measuring it, whether it is we are measuring it with a manual or whether we are measuring with an electronic blood pressure machine. So as a researcher, we should understand that simply there are 100 patients and we are getting 100 blood pressure values, and variation is there. So variation creeps into the data because of these three factors. What is important for all of us to understand that as a researcher, whenever we are collecting the data, by keeping the variability due to the measurement process and experimental material is small, we should try to reduce the variability because of point number 2 and 3. Then only the experimenter or the researcher have a better chance of understanding the variability difference due to the condition. This is the first point, and very important point. Whenever you are collecting the data on any parameter, you should try to reduce the error, measurement error, the measurement process and experiment. We should try to make it homogeneous. Then only point number 1 can be taken care of. So these are the three sources of variability. And in statistics, we define three kinds of variation. One is the planned systematic, another one is the chance or the random error, and third one is the unplanned systematic. So you can correlate planned systematic with the conditional factor of interest. You are just posing a hypothesis that a person who are suffering from a hypertension, his blood pressure will be high. Or a person whose body mass index is high, his blood pressure is going to be on a higher node. So this research question is something which you are planning to check out. Another type of variability is chance or the random. You measure your own blood pressure 3 times and you are going to get 3 different values. So variation is there, but this variation is just a chance variation or a random variation. And third one is the unplanned systematic, which is very important. You are just taking care of that blood pressure is being affected because of the BMI, body mass index. But there are various another factors also which may affect the blood pressure of the patient. So as a researcher, you have to do a proper literature review to take care of the fact that what are the various factors which are going to affect the blood pressure, and then only you should proceed further. Another aspect in statistics that you all should understand, that what we have discussed into the previous slide, that in statistics we always take a sample from the target population, and on the basis of this sample we try to draw inference about the target population. For example, the objective is to estimate that what proportion of children in UK are suffering from asthma. So we want to estimate this proportion. We take a sample from this particular target population. What is the target population? All school going children into the UK, and that they may be many millions. We take a random sample from these school going children and we call it the sample. And from this sample, we estimate that particular proportion, and then we can infer that the estimated proportion of person who are suffering from, or school going children who are suffering from asthma, is 7.5%. So there is a catch that you have taken a sample, and on the basis of this sample only, you are saying that 7.5% of the children into the UK are suffering from asthma. But if somebody else repeat the same experiment, he is going to get different value of the proportion. His proportion may be 8% or 9%, or even it can come 4%, because his sample is different. He is also draw a random sample of size 500, and from this 500 student, he may get only 4% of the children in his. So obviously there is a variation. So that's why whenever you estimate something, you talk also about the standard error. So this part will be also discussed in detail into the future lectures. This is another aspect of statistical calculation. But what is important is that to predict the behavior of the population on the basis of sample, data is the only weapon. If our data is not correct, or if we didn't collected the data in a proper way, how we get the data? We measure something and we note down the value. That means if our measurement process is not appropriate, then obviously our data is not going to be correct. And if our data is wrong, so whatever statistical calculation we are going to do to draw the inference about the population, that will be inappropriate. It means data is the weapon in statistics to understand the pattern of variability into the target population. So we should understand what is data. So this is a classical approach, and I hope that most of us have heard the name of these variable: nominal, ordinal, interval, ratio. But this approach we see in many research methodology class or basic biostatistics class. This is another approach of understanding the data, and that is termed as the modern approach of measurement level. So what we should do, that whether our data is categorical or a metric variable. First of all, we should divide our data into these two parts: whether my data is a categorical variable or whether my data is a metric variable. How it is decided? Very simple. Just look whether the variable or the characteristic which you are measuring, it contains a unit or it does not contain a unit. Whether there is a fixed unit of measurement or not. If yes, there is a fixed unit of measurement, then we will say that it is a metric variable. Otherwise, it will become a categorical variable. For example, if you are measuring the height of the patient, so there is a fixed unit of measurement. It may be centimeter or meter. So this height, weight, body mass index, various blood related parameter, hemoglobin level, platelet count, all these are metric variable because there is a fixed unit of measurement associated with it. And if place of residence, level of disease, or you can say stage of disease, see, there is no unit behind such variables or such characteristics of the patient, then we can say that it is a categorical variable. Now, within categorical variable, the data is again divided into two parts. One we say nominal, another one we say ordinal variable. What is ordinal variable? If our categories are kept in some order and it have got a meaning. For example, male, female, transgender. These are the three values of a category. Say gender. What are the three possible values? Male, female, transgender. If we arrange it in any order, it doesn't make any sense. We cannot say that male is bigger than female and female is bigger than transgender. It is a nonsense ordering. Hence, such categorical variable will be a nominal variable. But if the categories stage 1, stage 2, stage 3, stage 4, so these categories, these are also 4 categories of a cancer, and we will arrange it, then we can say that it is a ordinal variable. So in this way, what you have to keep 2 points into your mind. First, whether the variable or the data which we are measuring, it have got a unit. If the answer is yes, then it will be termed as metric variable. Otherwise, it will be a categorical variable. And within categorical variable, if the categories have orders have some meaning, then we'll say that it is an ordinal variable. Otherwise, it will be a nominal variable. In one very important point at this point, which I would like to discuss with you, that what is a discrete data and what is continuous data. So whenever within metric variable, whenever, say, for example, height of the patient. Now, if the next patient, you didn't see the next patient and the next patient is just about to appear into your chamber. Now, if I ask you, what will be the height of the next patient? What are the possible answers which comes to your mind? Whether you can count all those possible answers on your fingers, Your answer is no. So such variable is continuous metric variable. If all the possible outcome you are not able to count on your finger, then that variable is termed as continuous metric variable. And if all the possible outcome you, for example, number of children. So here children is the unit. What are the possible answer? 0, 1, 2, 3, 4, 5. So it is a discrete metric variable. So in this way, you can decide whether your data is discrete or continuous. So this statistical reasoning or data analysis, it uses 4 general approaches. One is the descriptive statistics that we are going to discuss today. Another one is the statistical estimation. I think next 2 days, parametric and non-parametric testing of the point number 2 is estimation and testing of hypothesis, that will be discussed tomorrow and the day after tomorrow. And then statistical modeling, so regression modeling, logistic regression, factor analysis, exploratory analysis, all those are some advanced level of statistical analysis. So all these 4 points will be covered in this workshop step by step. So today we'll discuss point number 1. So what is our objective? Our objective is to describe the data, or we can say to make the reader to understand your data. This is what the objective. So first of all, we try to present our data in the form of table. So if the data is of nominal data, though simply what we write down the name of that variable. It's because it is the categorical way. So all the possible categories we write down here, and here we write down the numbers, and then here we write down the sample size. So in this way, you have collected the information of 500 babies, in which 265 are male and 235 are female. Similarly, we can also write down the relative frequency. In relative frequency, we simply write down in bracket the percentage. For example, hair color, what are the 4 possible categories? Brown, dark, blonde, and red. 95 children data has been collected, and 49 of them are brown, for 27 are dark, 15 are blonde, and 4 are red. And in bracket, we can also write down the relative percentage, relative frequency, that is, or simply percentage. So 51% of the children have brown hair and only 4% of the children have got red hair. In this way, we can interpret this numbers into percentage more easily. Similarly, for the ordinal data, satisfaction with the nursing care, numbers, total number is written over here, and how this 475 is distributed among these 5 categories, that is noted down. Now look at this data, parity or gravida of the woman. Now, what kind of variable is this? Whether it is a categorical variable or it is a metric variable. You can write down in the chat box. Okay, it is a discrete metric. Very good. It is discrete metric. Yeah, it is a metric variable. Very good, very good. So most of you understand. It is a discrete also, and it is metric also. Why it is a metric variable? Write down in the chat box. Why it is a metric variable? What is the unit? What is the unit? If it is a metric variable, then certainly there should be unit. Month, pregnancy, counting, unit number cannot be counted, number of pregnancies. Unit is simply parity or child or gravida. That's it. So you can simply see, okay, order of pregnancy. So unit is parity. If a woman is coming 0, 2, so 10 parity. Okay, so this is a metric variable, and this is a discrete metric variable. Why? Because say after this woman, the next woman whomsoever is coming, you can count the possible outcome on your finger. You can count the possible outcome on your finger. So unit is there, that's why it is a metric variable. And since you can count all the possible outcome on your finger, that's why it becomes a discrete metric variable. Very good. Now, how to, if your data is a metric variable and it is discrete, so you can simply present your data in the form of the number like this. Parity, write down the possible outcome, and here you just write down the numbers. So the tables for discrete metric variable is just presented like the categorical variable. So there is a very thin line between the categorical variable and discrete, because categorical variable are also the discrete variable, and this is a discrete metric variable. So the presentation is similar. Take this another example. Total number of lesions. So here the unit is a stunt. How many stunts a patient may have? So answer is 0 stunt unknown, or 1 stunt, 2 stunt. So you can see stunts are the unit, and it is a discrete metric variable. Now, here birth weight. You can see the unit of measurement is the birth weight. So how you can, what are the possible, if a baby is just going to the born, what is the possible values of the birth weight? Can you count all the possible values on your finger? So that's why it becomes a continuous metric. Yeah, obviously the unit is gram. Here you can see it is written birth weight in bracket. It is written G, gram. The unit is written over here. But here single values, instead of just giving a single values, we are simply giving the class interval 1500 gram to 1999 gram, 2000 gram to 2499 gram. Like this, the class interval is being presented, and two babies, there are 100 babies, and 2 babies are born between this class interval, 5 babies are born between this class interval. Like this, how these 100 babies are distributed among these class intervals are. So simply there are, you might have got 100 birth weight. You have converted these 100 birth weight in this. So the reader is able to understand the pattern of distribution of the birth weight into the population, how the values are distributed into the population. So you can see that most of the babies are born between 2500 gram to 400 gram. We've got 27, 28, 27 and 2592. So there are few outliers also like this. So similarly, when we move to the graphical presentation of these 4 kinds of data. So if your data is nominal or ordinal data, pie chart is the one of the best option that you can prepare. You can simply see incidence of born by age. So this is a circle, 360-degree is all the angle, and the area covered is according to the how many people are lying in this. The 60% are of the age 15 to 64, 10% are of the more than 65, like this. Cause of the burns, so 55% because of the flame, scales 40%, chemical and electrical 5%. So you have just converted your table or those numbers into the figure, this pie chart, and this gives a 2-dimensional view to the reader that okay, most of the part is being recently when the election results are being declared, you might have seen these pie charts over there also. It gives a very simple presentation to our reader that how the numbers are how the numbers are distributed among different categories. Simple bar chart. So here in this example, on the x-axis, we have got cause of injury. There are 4 cause of injury. One, you fall, crush, motor vehicle crash, and others. So these are the 4 categories. And on the y-axis, we have got the number of patients. Okay, you can see. What is the very important to monitor into the bar graph is the gap. Notice the gap between the category bars. Okay, this is very important. Oh, so we have also got this cluster bar chart. So here on the x-axis, we have got the categories, level of physical activity. 1 is the lowest, 1 is the highest. And on the y-axis, we have got the patient in percentage. And these cluster are among the 2 groups, less than 600 mg per day and more than 1400 mg per day, and how the things are distributed in these 2 categories, these 2 doses among all these categories. So such things are termed as clustered bar chart. This is very common mistake that usually we do, that if we don't understand that our data is a discrete metric variable, we should prepare the bar chart for that. I have seen in various research articles that the things are presented by histogram. That is wrong. Say, for example, parity on the x-axis and on the y-axis number of mothers. Okay, and you can see the gap between these because 0, 1, 2. So these are the discrete variable. There is no continuity between 0 and 1. So if our data is a discrete metric variable, so for that, it is very important to prepare a bar chart rather than preparing a histogram. There is the logic behind it. But if our data is a continuous metric variable, then you can see on the axis birth weight, and there is a continuity 1500 gram to 199 gram, then 2000 gram. Like this, you can see that's why there is a continuity and there is no gap between these bars. So we say that it is a histogram. So on the x-axis, we have got the different class intervals, and on the y-axis, we have got the number of babies. So very simply, if our data is of these 4 kinds, so how we can prepare the graphs and table for such data, and that we should present or represent our data in this way, very simply. This is a very important graph, very famous graph and very useful graph, because as I told you that why we do the statistical calculation to understand the variability into data, and this box plot, or to be more precise, box and whisker plot, does this job tremendously. Here you can see that on the x-axis, we have got 2 groups, control and disease group, non-agiospermic long-term survivor of childhood cancer, 23 and 66. And on the y-axis, we have got SPM concentration. It is a metric variable. That's why unit is also written in bracket. This is a good practice that whenever you write down a variable name in bracket, you should always write down its unit, so the reader is able to understand that it is a metric variable and how you have measured this particular aspect. Now coming to this graph, now this graph is very beautifully, it divides the whole data into 4 parts. The bottom line is actually, this line it represents that 25% people are below this line. Out of 66, if there are 100 people, say for example, so 25 people have got values less than 50. Then 50% people have got the values, say less than 80. And 75% people or 25% people have got values more than 120. So this is the first quarter. second quarter, third quarter. So, and this bottom line is the minimum and this top line is the maximum. So it is a 5-point summary of the data, minimum, maximum, Q1, Q2, Q3, quarter 1, quarter 2, quarter 3. So the reader is able to understand that how the data is distributed, how this spam concentration is distributed in controls, and how this spam concentration is distributed in the disease group. Here, 25%. You can see the value is around 25. The median, or you can say this quartile 2, the value is around less than 50. So very, just by looking at these two, we can say that there is a significant difference between these two groups. And that's why the test and its p-value is also mentioned over. So this is a very complete graph which not only represent the variability or the distribution of the spam concentration in these two groups, and also says that they are significantly different from each other. So that's why this graphical presentation speaks a lot about your data. So now moving to the numerical summary of the data. So if you can look at this particular table, and I'm very much confident that most of you have seen such table into the research articles. If you have reviewed research articles for doing research, obviously you have seen such tables. What is the beauty of this table is that it actually provides you the baseline summary of the data or the important variables which you have collected into your study. So the first column is the name of the variable. The second column is the group, breastfed group, bottle fed group, and the last column is the p-value for group difference, for difference between these two groups. So this third column you can prepare after listening the lecture tomorrow and day after tomorrow. We will be focused on first these things. So the first variable, number of participants, in bracket they have written men / women. So there are 149 participants and 67 of them are men, 82. You can say this is explanatory. 182 are bottle fed who are in this group, and 93 are men and 89 are women. Now you can see age, and in bracket they have written the unit. What does this mean? The reader is able to understand that this is a metric variable. Height, centimeter, metric variable. Weight, kg, metric variable. Body mass index, bracket mein unit, metric variable. Length of breastfeeding, bracket mein unit, metric variable, metric variable, metric. All these have got metric variable, but as soon as it's come to the smoking history, there is no unit. Number, percentage, smoker, former smoker, non-smoker. So they have written the what are the three categories. Okay, social class 1, 2, 3, 3, 4, and 5. So this is the social class. So you can understand that whenever your data is a metric variable, you should write down the unit. Another very important thing is that, for example, age, they have written 23, 23, but here in bracket, they have written 20 to 28 and here 20 to 27. So this is a range you can say. But for height, they have written 170 and here they have written 10. For 160 and here they have written 9. Why these things they are doing? We'll try to understand. So, number, percentage, and proportion. So one of the very simplest thing that we can do with our raw data is to count it. For example, count the number of men and women into your data, count the number of individual with a particular blood group, number of individual with stage 2 cancer, or the number of newborn babies with Apgar score of 6 or less. Just count them and write down. If your data is discrete, you have to simply do it. Just count the various values in those categories and just write down. But if your data, another is mode, the mode or the modal value is the value in the particular data set which occurs highest number of time. If your data is discrete, so obviously mode is the best thing that you can do, but it is usually used very less into the research article. For example, the delivery method for the 22 babies in a day, what is the modal delivery method? So you can count that what is the most common way of doing the delivery into the babies. So, but it is not used. The reason is that there may be more than one mode. If your data is say discrete, so there may be more than one mode, or the values may be very much near to each other in different categories. So just saying that it is the modal value, this is going to give a wrong indication. And it is not useful for continuous metric variable. The mode is also not useful with discrete metric data when there is number of values are large. Only thing which is very comes into the favor of mode, that it is very easy to understand or very easy to determine. That's it. So next measure of central tendency is the median. What we do actually in the median, that we arrange the data in ascending or descending order and pick the middle value. 50% of the value should lie below this and 50% of the value should lie above this. Quartile 2, Q2 is its another name. Here you can see that here there are 5 persons in a group. You just simply arrange these numbers, their age, into the ascending order: 30, 31, 32, 33, 35. And this 32 is the median value because 50% below it, 50% above it. So since the middle value is 32, so the median age of these 5 people is 32 years. Now what happened that if instead of 5 there are 6 values: 30, 31, 32, 33, 35 and 36. So we just pick the 2 values. If the number of observation are even, so we just take the 2 values in between and take the mean of it. So this median value is 32.5. But what happens if the one person is, instead of being 36, it is of 96? Even in that case also, the median will be 32.5. Now this is the advantage of median, and this is also the disadvantage of median. What is the advantage? That it doesn't get affected by the extreme values. What is the disadvantage? The disadvantage also the same. It doesn't get affected by the extreme values. So as a researcher, you should be very much important for you to understand when we should use median and when we should not use median. I will just give another example. Another example is that, say, for example, if you go to a village and there are 50 households in that village, a question which you ask to those 50 households is about their monthly income. That what is your monthly income? Since there are 50 households, so you are getting the response. There may be some very poor households, some very rich households. So you are getting response: 5,000 is the monthly income, 7,500 is the monthly income, 18,000 is the monthly income, 22,000 is the monthly income, like this. But there are few houses whose monthly income may be around 1 lakh, 1.5 lakh, 2 lakh, if they have got good job in some institution or school. So when you take the mean of this data set, the mean comes out to be 35,000. So the interpretation of this 35,000, that the average income of this village is 35,000. It is a comfortable income, 35,000 each. But when you present the median of the same data set, it's come out to be 11,000. What does this mean? It means 50% of the people in this village are having got their income less than 11,000. And 50% of the people in this village have got income more than 11,000. So this is more informative or more appropriate, I must say. Rather than giving the mean, you should always give median in such cases when your data is skewed. When your data is skewed, there is a skewness into your data, then you should give median as a measure of central tendency rather than giving the mean. So median, it discards a lot of information because it ignores most of the values. So you have to understand when I have to ignore the values, when I should not. It is not much affected by skewness in the distribution, whether your data is positively skewed or negatively skewed. But it is not easy to determine by hand if your data is large. So you need us. But nowadays, this is not a very difficult task. And because of the available software and computers, very easily you can define the median. But you should mean the most used summary statistics or numerical summary statistics in statistical analysis. So when we should use mean, so when our data is normally distributed or nearly normally distributed, then we should, what is the mean? We all know that we just take add all the observation and divide it by the number of observation. We get the mean, or to be more precise, arithmetic mean. So what is the very important property of the mean? That it uses all the information of the data set. Every value is included for calculation of the mean. This becomes the advantage of the mean, and this again becomes the disadvantage of the mean. As the previous example, the mean comes out to be 35,000. So the mean is not appropriate in such case. Because of this, it is affected by skewness of the data. As a consequence, mean sometime might be unrepresentative of the data. It is not an appropriate summary statistics or numerical summary of the data. So the measure of location. So first of all, you have to understand what is the type of variable, whether it is nominal, whether it is ordinal, whether it is metric discrete, or whether it is metric continuous. So mode you can use for discrete data, nominal, ordinal, or metric discrete. Yes, yes, yes. But for metric continuous, you cannot use mode. Mode is not a appropriate measure of location. Median you cannot use with the nominal data, but for ordinal, for metric data, or for metric continuous data, median can be used, especially if your data is skewed. And you can not use mean if your data is categorical, either nominal or ordinal. You should not use mean. It is not justifiable because adding the ordinal values doesn't make any sense. In the mean, we add the values. Adding the ordinal values, it is a nonsense thing. That's why we should not calculate mean if our data is ordinal. But we should calculate mean when our data is metric and normally distributed. So the main thing that you should remember, that mean cannot be used with the ordinal data or numerical data because they are not the real numbers. And median can be used for both ordinal and metric data. Another thing that you should remember, that mean you should use when your data is normally distributed. Otherwise, you should go with the median. So now only just giving the measure of central tendency or measure of location, we should also measure how much our data is spreading, or you can say measure how we can measure the dispersion or scatteredness into our data. For that, we should use this few slides. Range is the maximum and the minimum value of the data. This is a very simple way to measure the spreadness of the data, dispersion into the data. So 2170 is the minimum value and 4140 is the maximum value. In this way, we can say that this is how much data is spread. But what if outliers are present? If outliers are present, then range is not a appropriate way to measure the dispersion into the data. In such cases, we should go with the quartiles. And I already tell you, quartiles actually divides the data into the 4 part. For example, the median divides the data into the 2 part. Quartiles divide the data into the 4 quarter. First quarter, Q1, 25% of the things lie below this. Second quarter, Q1 to Q2, 25% of the data lies in this group. And then Q2 to Q3, and then more than Q3. In this way, because of this, this is called quartiles. Divide your whole data into 4 equal part. Or so you can also give Q1 and Q3. Then only people are able to understand how your data is distributed. And box and whisker plot is a very good example for quartiles. You can see that here, this box and whiskers plots we are using for giving to understand the variability into the data. Another source of variation that we very commonly use is the standard deviation or variance. So what is standard deviation or variance? That we'll try to understand in this particular slide. So here we have got age, very small example. So we have got 5 numbers, 23, 34, 36, 30 and 29. These are the 5 numbers. Now we want to calculate the variation or standard deviation of this data set. What we simply do that, what we can do, just take the how much data is scattered or spread. So what is the idea that if we just calculate the mean of this data set and calculate the distance of all these observations from the mean. So if the things are very much close to the mean, it means the variation is less, or standard deviation is less. But if the things are distributed away from the mean, then we can say that in this case, the variation is more. So simply, this is the observation. Add all this 152. 152 divided by 5, it comes out to be 30.4. Now in this column, we calculate the distance of all these observations from the mean, x minus x bar, minus 7.4, 3.6, 5.6, minus 0. Then just take the average of all these distances. And when we try to take the average of all these distances, we have to add all these observations and it comes out to be 0. This is the property of the mean. Whenever you take the average distance of all the observations from the mean, it will be 0. So what we do, because some of them are positive and some of them are negative. So whenever you are going to add it, all will cancel out and it will become 0. So what we do that we square this distance. Okay, we square this distance here. And when you square the distance, the minus will become plus. Plus will become plus. So this is the square of minus, and then we get this value 101.2. And then we take the average. So 101.2 divided by 5, it will become 20.24. Now this thing is termed as variance. So the variance is 20.24. Since we have squared it to get the variance, So we take a square root of 20.24. 20.24 square root, it comes out to 4.45, and that is termed as standard deviation. Okay, so in this way, standard deviation or variance is being calculated into the software. Just average distance of all the observation from the mean. Now, when we should use range, if your data is nominal, so, or if your data is categorical, usually spread is not measured. In such case, we simply give the number, and in bracket we simply give the percentage. If your data is ordinal, you can give the range, or you can also give the quartiles. But standard deviation you cannot calculate if your data is ordinal. If your data is metric, range can be given if there is no outliers. You can give quartiles if your data is skewed, or you should go with the standard deviation if your data is normally distributed. So I will stop at this particular point of time and open the floor for question and answer. So you can ask questions.
Thank you so much, sir, for your very informative session. Now the floor is open for the discussion. So, participants, some questions are already, I think, in the chat box. So I think we can take
Okay.
first
Okay.
that.
Okay. So mean cannot.
I think those are more of discussion. So participants, you can write your queries in the chat box, or you can unmute yourself, and after that we will go for the hands-on. You can unmute yourself if you have any queries.
Good evening, sir.
Yes.
Sir.
Yes.
Sir, can you repeat the standard deviation and variance part once more?
Look, Priyanka, what actually we do that we just take the distance of all the observation from the mean, because our idea is to measure the variability into the data. How much data is, what is the spreadness into the data? So idea is that, okay, we just take the distance of all the observation from the mean. So when we take the distance and then we try to average it, it becomes 0. Whenever we'll add, it will become 0. So mathematics say, because some of them are positive, some of them are negative. So mathematics say square the distance. So we square the distance, all of them become positive. Now we have got the square distance. And then we take the average of these square distance. So it is termed as variance. It gives us an idea how much spreadness is there into the data. Since we have squared it, so we take a square root of variance. So the result is standard deviation. Why? Why we calculate this? Say there are two sections in class 10, section A and section B. The mean is 60. They have given the mathematics examination, board examination. The average marks is 60 in section A. The average marks is 16 section B. Standard deviation is 10 in section A and standard deviation is 20 in section B. What though mean just says 60 in both, but 20 standard deviation means some students are getting away marks. The marks are away from the mean in section B, but marks are very much concentrated to 60 in section A. All the students are performing very much close to in section A, but that's why this gives you idea that how much data is spread. But that we do if our data is normally distributed. But if our data is not normally distributed, then instead of giving the standard deviation, we should go with the quartiles. That is the catch. If our data is skewed, we should give median and quartiles. If our data is normally distributed, then we should summarize our data with mean and standard deviation. If you can see the slide, there is a one table which I was discussing here. Here you can see age 23, and they have get in bracket the spread is written by 20 to 28. but height 170 and 10. So this, it means the reader should understand that height is normally distributed. The mean is 170 and the standard deviation is 10. But age is not normally distributed, it's skewed. The median is 23 and this is the range. Similarly, length of breastfeeding, it is 3.33 month. It is the median value. What is the, you can see here they have given the range 0 to 18 months. It just suggests the reader that it is a skewed metric variable. But body mass index, weight, height, they have given the mean, and in bracket they have given the standard deviation. Okay. So you should present the summary statistics in such way, then only reader is able to understand, and you should also read the data in similar way. Another question, please.
Sir,
Yes.
how would we know? How would we get to know that our data is normally distributed?
You have to listen next session for this. SPSS, I will tell.
Okay. Okay, sir. Okay. Thank you, sir.
Sir, when we use Likert scale
Yes.
for any sort of data, some of the articles show that they have actually averaged the scores. That as per what you're saying, that is not the correct way to summarize the data.
Very, very important question, Dr. Dhanya. I am very much thankful for you to asking this question. Look, the Likert scale is there. We ask we take a subjective view of the respondent on a Likert scale. And how much you are satisfied with the nursing care, how much you are satisfied with the drug, how much you are, so 1 to 5, very set. Okay. So this one item is a ordinal variable. But why you are asking the satisfaction of the patient, and you are asking 10 items. 10 items. How much you are satisfied with the nursing, how much you are satisfied with the sweepers, how much you are satisfied with the resident, how much you are satisfied with the consultant. Then you add all these, his 3-4 numbers. So for a single respondent, you get his satisfaction level out of 30. So his satisfaction level out of 30 is, say, 24. It means you have converted your Likert scale when you add this you have converted these various responses into score. That score is a metric variable. Once it's become the metric variable, then you can use the average.
Okay, sir, I got
And
it.
you have to,
Probably
you have to give the name for that score. You have to give satisfaction score. This is the unit. Average is 20, average satisfaction score is 22 unit. But you should not use mean for a single Likert scale. That is not appropriate. You can use, software will give you mean is 3.4, but that is not appropriate. Say for example, the mean satisfaction score for the consultant is 3.4. But I'm saying the median is 4. It means what 50% of the people have ranked more than 4 to the consultant, and 50% of the people have ranked less. What is the quartile one? 1. 25% of the people have given less than 1 mark. So it is more informative. Rather than giving the mean, you should give median and quartiles in the single Likert scale. The reader is able to more understand the pattern of the marks, a pattern of the, you can say, Likert point chosen by the participant. That is what I feel. That is more informative. This summary statistics, that how you are summarizing your data, how you are presenting your data to the reader, is very important. You should not blindly just click the software and get the results and put into the table. You have to think a lot. Each and every value which you get out of your data calculation. So this Likert scale is actually when you add the Likert scale to make it a score, it become a metric variable. Then you can use mean and you can use parametric, non-parametric test. That is okay. I think I'm clear.
Yes, sir.
Hello?
Thank you so much.
Yes.
Hello?
Yes, please ask.
Sir, what is outliers?
Outliers. Outliers are the numbers, are the measurement which we didn't expect whenever we are measuring something. It is abnormal. When you prepare a box plot, so there is a box. What is the box? This is the Q1, and this is the Q3. In between, there is a Q2. So this is a box, and above the box and below the box, there are whiskers. All the things which are outside of these whiskers are termed as outlier. It is you can say 1.5% of the, more than 1.5% of the things. So say, for example, if you are measuring the platelet count of the patient, okay? So platelet count of the patient, you know the normal range, even 80,000, 90,000, you can say, okay, it is very, very okay. Okay. But if the platelet count are more than, sometime it becomes 12 lakh, 30 lakh, hai? So such values become outliers. Such values, you cannot use such values for your data analysis. Usual data analysis. So you should always check for these outliers into the data, because whenever you add these outliers for doing calculation of the mean or standard deviation, it will just give a wrong interpretation. Simply, the example which I've taken, the income of the 50 household. Few of them are getting 1 lakh, 1.5 lakh, 2 lakh. The income of the mean income becomes 35,000. Because of these outliers, the mean become 35,000. You should remove these outliers, take the homogeneous thing into the account. So there are
So can
various
you give
ways.
some examples from agriculture or plant pathology perspective?
Agriculture and plant for what? Outliers?
Yes.
Right now, nothing is clicking into your mind. I will try to give some in my theory session. Practical session. I will try to do something.
Okay, thank you so much, sir.
I think we can move for the hands-on session. So I think more of the queries will be solved there.
Okay. So since it is a practical session, and the software which we are going to use here in this practical session is the SPSS, and I am using the Mac version, so things are slightly different, only slightly different into the Windows version. So whenever you will open it, you can see the Excel kind of this thing into your here the columns 1, 2, 3 rows, columns VAR, rows 1, 2, 3, 4, 5, 6. So this is actually termed as the data view of this SPSS window. There is also a variable view, and you can see that what is happening. The variable view, name, type, width, decimal, level, etc. like this. So the data view and the variable view. Data view is very much similar to the Excel sheet. Here you can see it is very much similar to the Excel sheet. If you have worked on the Excel sheets, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and here A, B, C, D, E, F, G. Similarly, here in the SPSS, 1, 2, 3, 4, 5, and here instead of ABCD, they are writing short form VAR. Now, how we enter the data into the Excel sheet if I have to enter the data here, for example, there are participants, so I will just write down, say, enrollment number of the participant in this workshop, their name, their gender, their education qualification, then their age, like this. Weight, phone number, like this. We can collect the, and then here all the enrollment number, say 1, 2, 3, 1, 3, 4, name, say Ram, Sita. Here in the gender, we can write down male. Here we can write down female. Education, PG, UG, age 32, 29, weight say 72. Like this, we can do the data entry. More variables are there, it will. But how we can do data entry into the SPSS? Okay, here we cannot start typing. How? So as soon as we will click on this variable, so first of all, what we have to do, we have to prepare the blueprint of the data. So we should go to the variable view, and our first is the enrollment number. So we have to write down the name of the variable. It is enrollment number. What you have to take care that whenever you are writing the name of the variable, it should start with it should not start with a number. It should start with some alphabet, and there should be no space between the name. Okay. Now enrollment number. What is enrollment number? What is its type? So its type is okay. Its type is numeric. Okay, very good. Width. How much width it is going to take? Whether it is a decimal? No. So there is no decimal into the enrollment number. Here you can explain what is this. So you can write down enrollment number. Okay. Now values. So there is no need of putting values, because if it is a categorical value, then we can go for the values. Then here very important terms came. How many columns? Alignment. What is the measurement? Enrollment number, it is a ordinal, nominal. What it is? It is a nominal variable. And what is its enroll? What is the role of this variable? So it is just a variable which is used for none. It is just for identification. What is the another variable which we are taking care of? Name, gender, education. So another, here I will type name. So what is name? What is its type? Its type is string. Okay, it is a string variable, and we need 30 characteristics for this. Then gender. This is very important. Gender, for gender it is numeric, decimal 0. Okay, and here this is the gender. Then gender, here we go to the values. Just click on this. I will type 1 for male, add, and 2 for female, add. Okay. Got it? Then education, age.
No, sir.
Education, education, education. Again, I will click it numeric. Education is my categorical variable. Okay. Education is my categorical variable. Then we go to the values. 1 for say UG, add. 2 for PG, add. 3 for post PG, add. Okay. Then weight it is also a numeric variable. And here, since it is a, now here, we'll come to the, what is the measurement level of what? What is the measurement level of name? The measurement level of name is nominal. Then what is the measurement level of gender? It is a nominal variable. It is a ordinal variable. The level of education, UG, PG, it is the ordinal variable. Then weight is a, here in SPSS, weight is termed as scale. Okay, weight is known as scale. So weight is a, similarly height, HEIGST, height. It is also a numerical variable. We can make it 0. And the measurement level is the scale. So in this way, we have prepared the blueprint. And when we go to the data view now, you can see this will come like this. Enrollment number, name, gender, education, weight, and height. And you can see three dots like this. So it means it is a nominal variable. When you see things like this, it means it is a ordinal variable. When see a scale like this, then it is a metric variable or scale variable. Here name, you can see it is a nominal variable, but here A is written. It means it is a string variable. Now enrollment number 1, 2, 3. Okay, name, Ram, gender. So when you click on it, fill 1, education 1, weight say 67, and height say 149 centimeter. Enrollment number 132, say Sita, gender 2, education 2, this is 72, and height is say 151. Okay, this is how you can start doing the data entry. And as soon as you'll click on it, it will just give you the UG, PG. Okay, converting the numerical variable into like this. So this is how you can, before collecting your data, on what variables you are going to just fill all those, just prepare this blueprint. And as soon as you start collecting the data, you can enter the data into the SPSS like this. This is the smartest way of doing the data entry into the SPSS. Okay, but what if you have already done the data entry into the SPSS? Say here weight comes 69, and then just I will delete this phone number. Okay, now I want to call this data into the SPSS, or let me check whether I have got some Excel data or not. Just let me check. Spreadsheet. Okay. So there is a demo data. Okay. Yes, okay, there is a demo data. So serial number, height, weight, place of residence, and education level. Okay, so I will try to call this data into the SPSS. So how you can do that? Just go to the file and import data from the Excel. Okay, then you have to here go to that particular folder, since the data is on the desktop and the name of the data is the demo data. So just click it, and now it will show you the data like this only. Okay, serial number, height, weight, place of residence, and level of education. So click OK. Now you can see that data is being called into the SPSS. Now, what is the important serial number? It is taken as a nominal. Just go to, but serial number is not it is nominal. Height, it is a scale. Weight, place of residence. Okay, place of residence, and place of residence it is not a, it is a nominal variable, but the issue is that this 1, 2, 1, 2, so 1 urban. So here you have to go to the values and say 1 stands for urban, URBAN urban, add, and 2 stands for rural, 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 add. Okay. Similarly, level of education. So if you can see the level of education, what are the different values? 1, 4, 3, 5 is also there. So it is 1, 2, 3, 4, 5. So you have to just go to the values. Just say 1 for illiterate, 2 for metric, 3 for intermediate, 4 for UG, and 5 for PG. Okay. So you have just given the name to these numbers, okay, these categories, and when you go to the data view, you can see that you have now called the data from the Excel to SPSS, then you can do the data analysis. Now, since this data is here like this only, I will keep it here. Now, here you should go to the analyze. Okay, here you should go to the analyze, and in the analyze, you should go to the descriptive statistics. And in descriptive statistics, if you can go to the frequencies. Okay, in frequency, just you want to, if your data is discrete, you can simply select those things into that particular thing, or even you can also select weight and height if your data is discrete metric variable, and weight, assuming that it is also discrete metric variable. Then if you go to the statistics, you can just click on quartiles, you can click on mean, median. In the case of dispersion, whether you want standard deviation, variance, range, minimum, maximum, whatever you want, you can just click continue. Then in the charts, whether you want bar chart of frequency or percentage, just click on percentage, or you want pie chart, just click on it, continue, and just click OK. So here it will give you the output into the output menu. Say here you can see that place of residence, out of 20, 8 are from urban, 8 are from urban, 12 are from rural. In bracket, the percentage also given. Out of this 20, 5 are illiterate, 4 are metric, 9 are intermediate, 1 is UG, and 1 is PG. Okay. Like this, height, it is not appropriate. Tabular form, and then go to the pie chart. Okay, pie chart for urban, level of education, height and weight pie chart there, because it is software, it is a nonsense. Computer is an idiot box, so whatever you will put, it will give the output, but certainly you should take care of these particular things. So if your data is discrete, for that you can use this tab frequency. Okay. Or you can also remove these two, and then when you go to the chart, and you can click on the histogram, okay, and show normal curve on the histogram, click. So it will just prepare the histogram and prepare the whether your data is normally distributed or not. Since the number of observations are very less, so doing the normality test is not appropriate in this particular case. So this is one way of presenting the numerical summary of the data. If you go to the descriptive, so for descriptive, you can use weight and height. And then in the option, you can go and just use the mean, standard deviation, courtesy, skewness, and then continue. And this will present the descriptive of the data. No graphical something, just you can see it is just simply give you the minimum, maximum, mean and standard deviation. My favorite is in the descriptive statistics is the explore. So when we go to the explore, this tab will open. This tab will open, and in this tab, dependently, say I want to just know about the height and weight, and then statistics, descriptive statistics will give plots. Which plot? I want histogram, and then click on this normality plot with test. So it will also tell me whether my data is normally distributed or not. Then continue and then click OK. So it will give the descriptive of the height and weight. You can see the mean comes out to be 154. 95% confidence interval, they will discuss it tomorrow. 5% trim, 5% observation from upper and lower is subtracted. Then the mean comes out to 155. Median is also 155. Variance range. And then this is a test for normality, Kolmogorov-Simrow test and Sapro-Wilk test. The null hypothesis is that data is normally distributed, and here the null hypothesis is not rejected because it is coming out more than 0.05. It means you can say that your data is normally distributed. So you can use mean and standard deviation in this data. As most of the observation are close to this line, it means your data, it suggests your data is normally distributed. Okay, so this is the box plot. So this is how you can check the normality of the data. Okay. I will take another data set to explain these things to you people. So which data set I should take? Let me check. Okay, I will just try to open this data set. Okay, so this is a data set. Here we have got the variable time, status. Okay, this is a scale, Karno score, diagnosis time, average, and prior to this. So just I will go to the variable view, and I know that this time, it is a numeric, but it is a scale variable. So I will just convert it into the scale. Status. So I want to check whether this time, whether it is normally distributed or not. So that how I can summarize this time. Okay, how I can summarize this time. So for this, I will go to the analyze, then descriptive statistics, then explore. I'll just pick up this time, put it here. In the plots, I will just click on normality plot with test. Okay, then click on continue and then click OK. So it will give me this statistic. The null hypothesis data is normally distributed, and we reject the null hypothesis because it comes out to be significant. Both Kolmogorov-Simrow and Sapro-Wilk test. You can see also, then since most of these dotted line are away from this line, it means this data is highly skewed. So here also in the box plot also you can see that most of the data are outliers from this observation. Okay, it means when we are going to present this data, so what values we should present? So for this, we should present median 80, and we should present the quartiles. Here quartiles are not being, interquartile range are being calculated, but quartiles are not being presented. So for that, we should go through the descriptive statistics, frequency, and then select time here. And then in statistics, we should click on median, and we should click on where are quartiles, nothing else. Just continue and then click OK. So it will give me the median as 80, 24 and 24 and 147. So the median time for survival of the patient who are suffering from this disease is 80. 24 month is the first quartile and 147.50 month is the 75 quartiles. So this is how we should decide that whether we should go with mean or median, or whether we should go with median or quartiles and mean and standard deviation. This is how the normality of the data set can be checked. There is a very important thing that we can also do into the data. For example, if you look at the data set, which is this data set, that we have got height and weight, and we want to create a new variable out of these two variables. How I can compute that? So for that, I can go to the transform and go to the compute variable. And here I will type, say, BMI, and how BMI is being calculated. I am not remembering weight by height square, height divided by height divided by weight square, weight star weight, and keep this in bracket. Okay, and then click OK. So I'm going to create a variable BMI. It's okay, continue. I am going to create a variable BMI, height divided by weight square, and click OK. So it will prepare a BMI for me like this. Okay, you can see one more variable is being created, BMI, and just go to a transform. Another thing is very important, that you should understand that you want to record the variable into the different level. For example, I want to record height. If I will go to the analyze descriptive statistic frequency, just for the height, I just want to see the continue, then click OK. Not pie chart. I want to see the, just a minute, frequency. I want to see which chart I want to see. Okay. Just go to the analyze descriptive statistics frequency, and I want to quartiles. Nothing else I want. I do not want. I just want to see the quartiles. So the quartiles are 146, 155, and 168. So what I'm trying to do, that I will prepare a, I will just want to create a new variable out of the variable height less than 140, 140 to 150, like this. Okay. How I can do that? So I will go to the transform, record into different variable. I want to record height into different variable, and I will name it HEIGST height underscore category cat, and change old and new values. So what is the old values? Range lowest through 140. So all the height which is less than 140, I will code it as 1. Then range 141 to 150, I will code it as 2. Add. Then 150 50, and then I will just range highest through 151. So I will just converting height into three categories: less than 140, 141 to 150, and more than 150, 1, 2, 3. Okay, continue and just okay. So when I look at the Excel sheet, it have prepared a new variable height category for me. And here I have to just label it again. One stands for less than, or I can just simply type less than 140, add. 2 stands for 141 to 150, add, and 3 stands for more than 150, add. Okay, so this is what is happening. I have simply converted height into height category. Okay, so you can see, and if I'll just click on this, it will give you more than 150. All these are, this is one which is lying between these two. And if I will take the analyze descriptive strategy frequency of this height. Okay, so it will give me the bar chart, and just a minute, analyze descriptive statistics frequency. I have to check display the frequency table. It will also give me the frequency table. So out of 20, 4 are lying in this group less than 140, 5 are lying in 141 to 150, and 11 are lying more than 150. This is what the bar chart is also suggesting. So this is very important. Transform compute variable, record into different variable. One also very important thing that you can do in this, that sometime you have to you want to select only the cases who just you want to do the data analysis for the male. So you can just select all the conditions. Okay, and then you can execute it. So there are various ways of, if you want to split your file according to the place of residence, compare group, just click and click OK. And then again, if you go to the analyze and descriptive statistics and say frequency, if you want to
I didn't get that. Could you try again?
just if you want to just click OK. So what will it will do the separate analysis for rural and urban. If you'll just go to the split file, so it will split your file like this. Okay, so this is the basic things that you can do. Then you can also go to the graph, and then in the legacy dialog, and then you can use the bar chart, simple bar chart, define bar chart. You can prepare for, as I told you, level of education. Okay. Then click OK. So here also you can prepare the bar chart like this. Okay, you can see. Again, go to the graph, legacy dialog, bar chart. If you want to prepare the cluster bar chart here, not only you have to prepare the level of education, you have to also define, okay, according to the this. 2 categories you have to select, then click OK. So it will prepare the cluster bar chart like this. Okay, analyze, graph, legacy dialog. Okay, bar chart is there, pie chart. You can also prepare from this, or you can also prepare the way I have just, or here, legacy dialog, box plot. Here you can go simple box plot, define, select height, Okay. Then click OK. So they will also prepare the, no, sorry. It is not like this. Box plot, simple box plot, then define. Click reset. Oh, no. OK is not highlighting. Summaries for the groups. Variable is this, category axis. So it is preparing the box plot for different categories of height. So in this way, box plot or histogram you can prepare for height. Just click OK. So it will also prepare the histogram for the height like this. So in this way, graphical and numerical summary you can do into the SPSS. Okay, if there is any query, you can ask. I'm stopping here for taking the questions.
You can unmute yourself. I'm just allowing you. Yes, please unmute yourself.
Good evening, sir. Thank you for this really informative session. Just requesting if you could please repeat the decode option in under transform tab, sir.
Okay.
Thank you.
So why this is being done here? Sometime what happened? I will just take another example. Okay, why it is important. So what I'm doing here is that I'm just I'm extending this data. Not this data. Just let me close it. Don't save. There's one more data set, demo data. Okay, just I'm opening this demo data. Here, I am just taking gender. These are the data on the 20, and here I am typing male.
We're unable to see your screen, sir.
Sorry. Just let me screen share.
Thank you.
Okay. So what this is again the data on the Excel sheet. I've called this data. I will call this data, but here I am typing male, FEMA, female, male. You can see what I'm doing. Okay. So sometime it is M only. Okay. Sometime it is F only. When the data entry is going on, reality is like this only. Okay, like this. So say this is the data set. Okay, now this is the data set. What I will do that I will call this data set into the SPSS and then just okay. Go to the file, import data from the Excel. My data is on the desktop and its name is demo data. Just click on it. Okay, and just click OK. So now you can see, no, just a minute. I have to save it. Just save it and just close it. File, import data from the Excel. Yes, now you can see male, female is coming. Okay. Just click OK. Now you can see what actually is happening here is that this data is male, female, male, female. I want to convert this data into the categorical variable. It is a categorical variable, but it is not entered in the, and here you can say it is a nominal variable, but it is a string variable. You can see type is string. This is not an appropriate way of entering the data. So how we can do that? How we can do that? So first of all, what we have to do? First of all, we should go to the transform, record into the, we can use record into the same variable, or we can use record into different variables. So I will just record into different, click gender, and here I will name it as gender, say C, gender clean. It stands for clean gender, and change old and new values. What smartly I have to do? I have to write down MALE male, its value is 1, add. I have to type MALE male and its value is 1, add. I have to type M, its value is 1, add. I have to type female, its value as 2. I have to type FEMALE because it is case sensitive. That's why. And I have to type F. Its value is 2. So all the things who are represented by MALE, small, capital, or small m, they will be treated as 1. So I have recorded. Just continue and click OK. So one more variable is created, just adjacent to this. This is this. I will just keep decimal 0. Okay, you can see 1 2 1 2 is there. Now I will go to the values and I will type 1 for male, add, and 2 for female, add. Click OK. Now if I go to the, you can see, okay, you can see that how this, and then when I click on this number, the coding will come. When I click the, what is the behind this male female 1 2 1 2 is there. This will help you when you will do the parametric and non-parametric test. This is going to help you a lot, because in non-parametric string variable, it is not going to take the string variable. Now the look here, the gender is string, but here the gender clean is numeric. So in parametric and non-parametric, only numerical variable they will take for the analysis. They will not take a string variable for the analysis. Okay, I think it is clear.
Yes, sir. Thank you so much for your time.
Okay.
Sir, can SPSS help in interpretation of the data? Because we are
No.
getting some
No.
means
SPSS doesn't, yeah, in the non-parametric, they are just presenting the table like this only. But interpreting the data, it is not going to help. It will just calculate the things and give it as the output. That's it.
Sir, can we?
Could you please
Sir,
explain the
can we-
split file thing once more, with why we are doing it, and
Again, Sonali, again, what?
so the split file.
Which site?
Split file.
A split file. A split file, sometime what happen now, if our guide or people ask that do the data analysis separately for urban and rural, or do the data analysis separately for control and case. Okay. So for that, you just go to the data and you just split your file. You can split your file according to the category. Here, for example, you can split file according to the gender. As soon as you will do it, just click OK. And whenever you do the analysis, ये तो कुछ और data खुल गया. Sorry. Just a minute. So it will simply it will simply just in the output, it will simply just give you the result separately for those split file. That's it. Okay. Go to the analyze descriptive statistic frequency. I think here. Just I didn't know that which here. Say if I go to the data split file and I will use this okay, gender, then click OK. And whenever I will just go to the analyze and do any analysis now in the SPSS, now it will give separate result for male and female. Here you can see separate for male and female, height distribution male and female. Even if I will prepare the say charts, okay, pie chart, continue, okay, it will prepare the different chart for male and female because my data is in the split format. Okay, that's why it will give the output like this. Whatever analysis I will do, but again when I have to just reset it and click OK. So now the split file is off. Here you can also read into the split file off. Then again, if you do the analysis, it will start doing the analysis for the separate. So it is just a thing that you need not to repeat the analysis for the different, just you have to pick one category that you want the separate analysis for all this category. In this way, the split file is being used. If they ask, this is one
Got
of
it, sir.
the
Thank you.
advantage.
Sir, what is string variable? Can you please elaborate?
Only alphabets you can use in string variable. String means
Thank you, sir.
Sir, can we apply filter in SPSS? If export data we have to taken from desktop, and can we apply filter?
Yes, you can apply filter. You can apply filter. Here you can see when you go to the data and you can go to the select cases. Okay, here you can see you can just use filter variable. Okay, for example, here just use gender as the filter variable. So what it will do, it will filter out unselected cases. Okay, or you can say if condition, if this gender is equal to 1 means male, continue. Now you have filtered. Okay, filter out unselected cases, click OK. So now what happened when you go to the data view, you can see that here this crossings are there. You can see cross like this things are there. All the females are filtered. So whenever you use any analysis now, for example, if you weight and height, it will just give 10 observation of male only because females are being filtered. Got it? So in this way, just again, if you want to go to the select cases, just click on the reset. Okay, click OK. Now you have again chosen all your data, descriptive statistics, frequency. Now if you'll just click OK, it will give the frequency of 20 observation. So in this way, you can use the filtered data according to the category. For this category, if you want to use it, just go to the data, select cases, if condition, if you want for male only. So for this, just put this gender C, and I want for the female only, just put filter the data who is female only. Then continue and OK. Now again your data is filtered, and whenever you do the data analysis, only female data will be analyzed. Only the female data analysis can be done. Okay.
So, can you, sir, can we repeat how to categorize the data in SPSS one time more, sir?
How to categorize the data? Yes,
how
we
to
can do that.
categorize?
We can use it. You do that again. Just select the cases.
Mine, yes, sir. जैसे BMI सर होता है, BMI में
Got
हमारा
it.
less than 18, more than 18.
That, okay. So this is for example, weight data is there, na? Weight data is there. So I will simply go to the transform, recode into different variable. I will just reset it. Now I will select weight. So I will name it weight category, WEIGST weight _ C. So I will name new variable weight category change, and then old and new values. So what I will do, I will just take range lowest row. So all the value less than 40 kg is 1. All the values who are between 41 to 60 is 2. And all the value between 61 to say 80 is 3. Add and range highest through 81. Just you have to take these numbers should be exclusive class interval. 4. So what I simply did, I simply divided the variable weight less than 40 kg, 41 to 60 kg, 61 to 80 kg, and more than 81 kg. Okay, this is how I have done it. Just click continue and then click OK. Okay, so what will happen? You can see in the last one variable is being created, weight C. Just click on it, go to the values, 1, write down less than 40, add 2, 41 to 60, add 3, 61 to 80, add 4, more than 80, add. Okay. Now when you go to this, you can see that you have converted your weight. Okay, you have converted your weight variable into the categorical variable like weight category. You can see 81 is written as more than 80, 44 comes under the 41 to 60, 74 comes under the category 61 to 80. Go to the graph, descriptive statistics, just select this. Okay. And click OK. So it will give you the output like this. Okay.
Thank you, sir. Thanks.
Hello.
Yes.
Hello, sir. Thank you so much for the session. Sir, if you can just explain test for normality.
Test for normality.
Yes, that part.
Test for normality. For doing the test for normality, you have to go to the descriptive statistics, then go to the explore, and in the you have to select height. You want to check whether height is normally distributed or not. Then go to the plots and select normality plot with test. Then continue and OK. So as soon as you will do this, you will get this table test for the normality. 2 tests are being used, Kolmogorov-Simrod test and Saproville test. The null hypothesis for Kolmogorov-Simrod test is that data is normally distributed. And you can see by significance that the null hypothesis, you are failed to reject the null hypothesis. It means data is normally distributed. Both tests are saying that data is normally distributed. It means your height is normally distributed. This is how you can test a particular metric variable into the SPSS. And accordingly, you can decide whether I should use mean and standard deviation, or whether I can use parametric or non-parametric set. So testing of normality is very crucial if your data is metric.
Sir, can I ask a question?
Yes.
Sir, you mean to say p value is less than 0.05? It means that data are normally distributed by default.
No. I'm saying the null hypothesis is that data is normally distributed. If
Okay,
p value is more than 0.5, okay,
right.
so we fail to reject the null hypothesis.
Okay,
Got it? We fail to reject the null hypothesis. Whenever the p value is less significant or less than 0.05, then only we say that the null hypothesis is rejected. But here, then we fail to reject the null hypothesis. So whenever the p value is more than 0.05, we say that, okay, the data is normally distributed. Here the things are reverse.
okay, thank
Can we export this data into Excel file? Means
Yes,
after the changes.
we can export this data into the Excel file. Just we have to go to the file and just click on, this is the output file.
Yeah, this is the
And then we can click on save as. Okay. Just a minute. File and export. Here you can see export. And whether you want the output into the Word or RTF file, or whether you want, here you can see lot of options are there. Excel. Just click OK. So it will convert and export all your output into the Excel file.
So if we need to change in Excel, so we can do it there also.
No, this usually people do when they have to copy the results from here to their manuscript. So people usually convert these output into the Excel or the Word file, and they just pick up the things from there to their manuscript.
Okay,
Hello, sir.
Hello.
Can you give, hello?
Yes.
Sir, can you give one scenario where we can use mode as summary statistics?
For example, if
Because I have never seen in any
Yes,
articles
that's why
like
I'm saying,
mean and
yeah, you are right. The thing is that mode is used when your data is of discrete nature. And when the data is discrete, in that scenario, we simply write down the numbers in bracket, we write down the percentage, because it is more informative just than giving the mode. That's why mode is rarely used. Okay. Just mode is just okay, it is a thing which is just the representation. What is the things which is happening again and again. So in that scenario, that the model, for example, what is the model value of shoe size in this city? So you will say 7. What is the model value of shirt size which are sale on Amazon? You will say 40. In this way, it says that 40 is the shirt size which frequency of selling is maximum. So in that scenario, mode is used more. Yes.
Sir, I have a question.
Hmm.
How to remove outliers from dataset?
How to remove outliers from the
Dataset. Yes, sir. Yes, sir.
You have to identify which are the outliers into your data set. Just there is very simple way. Just if you go to the SPSS, okay, just go to this. For example, just click on hide, right click it, and just sort ascending. So it will sort the data set into ascending or descending order, and you can see whether these values or these smaller values, whether they are very, and then you can just filter it out, or you can just delete it, and then you can do the data analysis. There is also various ways to not only deal with this missing observations also. You can use in SPSS how to deal with the missing observation, but outliers, to identify outliers, just go to the graph, legacy dialog, prepare the box plot. Okay, define it, select just a minute. Analyze this box plot, separate variables. Then click OK. So whatever things are coming upper than this whiskers or lower than this whiskers, they will just represent the outliers. Here in this data, there is no outlier. But whenever you prepare a box plot, and you will see the observations which are above and which, for example, if I just show you how to identify the outliers in SPSS, this is very simple. Just I'll open this data set. I want to see the outlier in this time. So what I will do, I will go to the graph, and then I will go to the box plot, simple box plot, summarize the separate, define. I will select time, and then I will click OK. So here you can see that serial number 75, 70, 78, 58, 83, 170, 79, 136, 132, 82, all these are outliers. Okay, all these numbers are outliers. So I will just note it down and just remove these, and then I use this is how I can identify outliers in SPSS. Okay.
Yes, sir. Thank you, sir. Thank you, sir.
I think we can, participants, we can stop here because time is exceeded. So if any further queries, you can ask to our expert. So, sir, you can.
Thank you very much. Very informative. Very informative. Thank you, sir.
Thank you so much, sir.
Thank you.
Thank you for active participation, and I'm sure
Really,
Dr.
thank you,
Anup sir has recently dealt with all the queries. This is the first session, and 6 more days are also there with you. So have patience. So all your queries will be sorted out by our experts. So thank you all, and thank you. Yes, sir.
Sir, can we share this video on WhatsApp or any group recording?
Yes. Recording will be provided to you on your registered email. You
Thank
can
you.
download it and practice further.
What I just tell you to take a home take message for all of you, that you should every time you should try to identify the type of data. Remember, categorical or metric. If the unit is there, it is metric. In SPSS, scale name is there. If a unit is there, it is metric. If it is not, it is categorical. Okay. Just try to identify. Second thing that you should try to identify, if my data is metric variable, whether it is normally distributed or it is skewed. If it is normally distributed, we should give it with mean and standard deviation. If it is skewed, we should go with the median and quartiles. And if my data is categorical, just give number in bracket, just give percentage. This is how I should summarize my data into my research article. That's it. This should be the home take message for all of you today.
Thank you, sir.
Hello, sir. Hello.
Thank you, sir. Yes.
Hello, sir. I don't have any software SPSS, so I can practice it for any.
So you can download the trial version. Timing, and because this
Sir,
because this is a paid version. So
share the link of trial version of SPSS if you have.
Okay, we'll see and we'll send you the group.
Okay, thank you.
Sir, can you please share the recording today? Today's recording?
Yes, we will. Yes, for every session we'll send you the recording registered. Yes, email ID on your email.
Okay, sir.
Yes.
Thank you, sir.
Thank you, sir. Thank you so much, Dr. Anup, sir, for very informative session.
Hello, Dr. Anup. How are you?
Yes, fine.
Very. You have taken very long lecture.
Sorry, yes.
But actually, very.
Yeah, very informative. You have nicely, and you have solved all the queries to other respondents. Thank you, Dr. Anup. Thank you. I think you might have tired now.
Sir, you are there. I'm sorry, sir. Okay.
Thank you, sir. Thank you so much.
Okay,
Thank
sir.
you,
Good
Dr.
night. Good
Dhananjay.
night. Good night, sir.
Okay, good night. Good
Good
night.
night, everyone. See you tomorrow. Thank you all.
Thank you. Bye.
Thank you.